Well, happy Saturday to you all. This is Storm Track 7 meteorologist Robbie coming right with this week's edition of Weather Wonders. Now you'll notice a lot of cloud coverage behind me. If you look out the window, it's probably what you're seeing right now as well on this Saturday morning. I sure wish we had a little bit more blue sky, a little bit more sunshine out there, but this is what we typically see during these winter months, of course, and that's what we're going to be looking at here. Why is that the case? And I even throw some stats, some numbers at you of what we've seen so far this winter compared to this past summer. So let's dive on into it right now. Again, this all starts with the seasons, of course. Now, take a look at this. Again, just revolving around the sun. Of course, January 1st, first day of the year. Go figure with that, of course. But then we have the vernal equinox, the summer solstice, and then the autumnal equinox, and, of course, the winter solstice. That was the most recent event, solar event, we'll call it, as of late. Next, of course, is the vernal equinox before we get to that summer solstice. That'll be on March 19th. But again, that's out of the picture here. What I really want to focus on is the summer solstice and the winter solstice. So let's start off with the summer solstice here. Lots of solstice in this segment right here, but of course we're going to start off with this. The summer solstice is June 20th this upcoming year, but the main point I want you to figure out here, look at here I should say, is the Earth's tilt. Of course the Earth is on a tilt, its rotational axis at least, is tilted by an angle of 23.5 degrees. So during the summer months, the northern hemisphere, I'll point this out for you as well, as you can see, it's more in direct line with the rays of the sunshine, so more direct sunlight is falling across the northern hemisphere, hence the United States, of course, and our general area. Now, you flip over to the winter solstice, it's December 21st of this upcoming December. Now, what you'll notice again, on the flip side, more of the direct sun rays are across the southern half. That's below the equator, of course, the southern hemisphere. Now, the northern hemisphere, where we're located, of course, we're not receiving as much direct sunlight. So with that, how does that impact, how do these solstices or how do these seasons impact, say, the temperatures down closer to the ground, of course? So let's start with the summer months here, June, July, August. Of course, like I mentioned, we receive more direct sunlight. That's indicated by these yellow arrows here. So with more direct sunlight, at least bouncing down to the surface, we're technically warmer at the surface. That's why we have these warmer temperatures, of course, during the summer months. It took a bit to an extreme this past summer with those triple digits, of course, and record temperatures. But during the winter months, it's a bit different. Of course, less direct sunlight, so it will be cooler at the surface. And with that, if it is cooler at the surface compared to above our heads, that's known as a temperature inversion. Now, there's a lot going on here, but I want you to focus on that blue line, as you can see. This is basically observations from a weather balloon in Davenport just a couple of days ago. But the blue line, that's below freezing, and it increases with height, of course. So the higher up you go in the diagram, the higher up in the atmosphere we are. Now, this red line, that's the temperature line, and the green line is the dew point. As you can see, close to the surface, they're close together. So that means the air is saturated, or there's fog, or there's a cloud, low-level cloud coverage. Now you can see at the surface, the temperature is 34 degrees. At this next line, though, say 5,000 feet up, it's about 44 degrees. So warmer, more moist air is above it, above the surface, with cooler, more dense air below it. At that boundary is where we technically see this temperature inversion and this deck of cloud coverage begin to form, or these stratus clouds. It's exactly what we're seeing this morning. But again, just to give you some stats here of what we're talking about rather than sticking on the why behind all this. So let's look at the summer months. This was this past summer in Waterloo, the first 2 months of summer, June and July, combined no cloudy days. As you can see, 19 clear days in June, 24 clear days in July. But so far this winter, looking at December and January, 13 and 15 days respectively, that were completely cloudy, if not overcast. As you can see, almost 40 to 50% of those respective months. So that's 28 days total this winter. That's almost about 45% of our winter so far. That's compared to no cloudy days this past June or July. So that gives you a little bit of a reason why we see more cloudy days during the winter months compared to the summer months. And just some stats and some numbers to explain why we actually see that. But if you want to find out more information, be sure to check out the blog, Schnack's weather blog, of course, on kwwl.com under the weather tab. Be right back, though. We'll have more in just a bit.